Okay, hello to video number 16, the video of the CCNA 203-1 exam preparation for the month of November as well as for December. That should be the last video for the months of 2020. Yes, in the previous video number 15 we have discussed 20 questions about both September and October update. In this video I will also discuss about another 20 question for both November and December, starting from question number 1 right now. Question number 1 will be referred to the exhibit. An engineer configured the New York router, which is this one here, with the state routes that point to Atlanta and Washington sites. Which command must be configured on Atlanta and Washington routers so that, be careful, each one of them will be able to reach the loopback 2 of New York. This is not talking about making Atlanta be able to reach Washington through New York and vice versa. It's not in that way. The idea here is only about making Atlanta and Washington, both of them, be able to reach this loopback interface of New York. I don't care about the address as much as I care if I wanted to reach its destination or any other destination that might be useful. I need to reach through that link and through that link. But the catch up here is that in this question you must choose only one answer, because there is no choose two here, so that you would take two answers. One of them is for Atlanta and the other for Washington, just like the same topology we have seen in previous videos. So one single command of those 5 commands will be enough to be copied and pasted on both Atlanta and Washington, so that in the end both of them will be able to reach LO2 of New York. IPv6 route, so this is a static IPv6 route for everything. It's a default static route of IPv6 towards serial 001. If I configure this command on Atlanta, there is no serial 001 on Atlanta against or opposing to New York. It's only serial 000, and I can also not configure that command on Washington. So A will make no use for me if I use that command on either Atlanta or Washington. B, IPv6 route, again 0/0, meaning there is no colon here, and since there is no colon, this indicates that this language or this address is a decimal address, not a hexadecimal address, because there's no colon at all. So it's not a MAC address, surely it's not an IPv6, and thus this command is mistaken, because this is an IPv6 route for an IPv4 address, so this is mistaken. C says IPv6 route everything towards serial 000. I can configure a default static v6 route on Atlanta, sending them first to serial 00, and thus they will be able to reach New York. On the same time, if I configure the same command on Washington as well by making it like a copy and paste only, also Washington has a serial 000, and that will make it be able to send its packets toward New York successfully. So C is correct. For D, this is an IP route, and this makes no sense, because the destination IP address will be an IPv6 for packets heading for loopback 2, because loopback 2 of New York is an IPv6 address, and thus I need an IPv6 routing protocol to do that. That way an IPv4 route will not work. Finally, routing IPv6 static route default to 2000::2 should make you say no immediately, because this is stating here the next destination for the static route. This means that in Atlanta, if I configure this command, this means that if you wanted to use, or if you wanted to send anything by default, just send it to 2000::2, because it's on the other side of my interface. This means that 2000::2 should be on this interface, and I need a command that works on both Atlanta and Washington. So I take the command, copy it, paste it in Washington, and Washington will understand that there should be an IPv6 address of 2000::2 on the other side of its interface, meaning here. making a New York router have a duplicate IPv6 address, having the 2000:2 on both serial 000 and serial 001, which makes no sense. So E is not acceptable from an engineering perspective or designing perspective as well. C is the only correct answer today, and we should move to question number 2. What is the function of the remote access VPN that we have talked about in chapter 5 of the CCNA course? This is what happened in 2020 when there is a pandemic. All the companies worked from home, or maybe perhaps most of them, not all of them. What happens that usually you go to your office, you connect to the DHCP server of the office or the enterprise or ISP company or bank that you work in. You're gonna get an IP address from the local network there, and thus you will be able to access the devices. What happens in home is that you have a totally different network, far away from the network of your company that you work with, so you will need a remote access VPN to make your device virtually create a tunnel and a network, a private network, to connect your device to that far network or that remote network, like directly, virtually directly. And this is what should happen by a remote access VPN, and we did talk about that in chapter 5. So it uses a cryptographic tunneling to protect the privacy of data for multiple users, but simultaneously. This could be correct in some cases, but not in that remote access. This is not something about the main goal of a remote access, so no, I'm sorry. Used exclusively when a user is connected to a company's internal network. No, this is not for a local connection. No, not at all. This is the opposite of that. Establishes a secure tunnel between two branch sites. We can say this is a DMVPN, not the remote access. The remote access is clear. It's to allow you to access the network remotely. That's it. Access, not connect. Oh, through the WAN, not in that way. Allows the user to access a company internal network resources through a secure tunnel, and definitely then, since there is a tunnel, then you are on the other side of the tunnel remotely. So D will be the only correct question today for this one. Question number 3 says, which CRUD operation modifies an existing table or view? We have talked about that in chapter 7 when we have talked about the management applications and such, like Ansible, Chef, and Puppet. They use HTTP. Developers and programming engineers uses the HTTP verbs and CRUD so that they can create the APIs, etc. Which CRUD or HTTP verb is the one responsible when you want to press a command or create a new command by the XML language or JSON or HTTP to make use of, modify, or an existing table or a view. A view means a table, like show IP interface brief. This is a view. Show IP route. This is a view. Okay, so read is like the get. You would like to read the routing table, so you hit the command show IP route. Read is the one used for that. So this is not to modify something existing already. Create is like when you want to put something new, when like interface fast Ethernet 01 IP address 1111. This is a create. Replace and update, and there is a difference between them. Replace is by erasing a command and start pasting another one. Like if you access an interface that already has an IP address, type a different IP address, this will overwrite, so this is a replace. But update is when you want to modify something that is already there, like an interface that has a description and has a no shutdown command but does not have an IP address. In that case, you are modifying something already existing. For me, I will choose D as a CRUD. And by the way, no, I'm sorry, as a CRUD operation to modify a command that is already existing. Okay, question number 4 will be, what is a DHCP client? The guy that sends a broadcast message, they're asking for an IP address. It's a workstation, correct, that requests domain name associated with its IP address. This is something about DNS? No. A host might be that is configured to request an IP address automatically once it's operated, like your desktop computer or a laptop. This will work in that way. A server, no, you either a client or a server. So sorry, I'm not reading that. A router could be, because if you have a router, one of the interfaces can have the command of IP add or IP address DHCP, and thus it will ask the adjacent router or server to give it an IP address, to assign an IP address to interface fast Ethernet 00 perhaps. So a router that statically, and we know that DHCP is not something static, it's something dynamic host configuration protocol. So not D, only B is correct today, and we cannot use a different one. Okay, question number 5 said, what is the same or yes for both copper and fiber interfaces when using the SFP modules? Your question will be, yeah, okay, so what are the common characteristics between copper and fiber optic interfaces? They support inline optical attenuator. There is nothing called an optical attenuator or any optical features in the copper interface, so a copper interface cannot share the fiber optic interface with these. They provide minimal interruption services by being hot swappable. This is correct, and that means that whatever type of interface that you have, whether it was a copper, a port, or a fiber optic port, and there is a cable connected in it, and you wanted to swap that cable in 2 seconds just by unplug and plug a different cable on both sides, does that have or require any prerequisites? No, you can do that immediately without any prerequisites or configurations or commands, and this is what it's called the hot swappable procedure. You can do something immediately and you can avoid interruption by that. So B for now is correct. They offer reliable bandwidth up to 100 megabit per second in half duplex. Fiber optics starts from a gig, and the most important, full duplex, so not C. D, they accommodate the single mode and multi-mode. We have talked about that in chapter 1 in the course, and this is an exclusive specification or feature of only the fiber optic technology or ports, not of the cables, not of the copper at all. So this is not something common or to be shared between both the copper and fiber optic. When using the rapid per VLAN spanning tree, I've talked about that in the previous video. This is duplicated. How can you guarantee that a switch will be the root bridge for VLAN 200? By making it having the lowest bridge priority. Make the priority as a non-acceptable number because it's a maximum of 5 digits, so not even 6, and in both cases this will be incorrect. Make it 38 million and a half. This is also incorrect because it's too big, not acceptable. There is no such number supported in Cisco switches, and to make guarantee a switch will be the root bridge, make it having the lowest priority. So it's either by making it priority 0 or primary. This one will stuck, and sometimes if another one was configured as priority 0, make sure that you use priority 0. I did use root primary. It worked in some cases, in others it caused me some troubles. Question 7 says, an engineer must configure inter-switch VLAN communication. So by this is mean sending VLANs through a port between a Cisco switch and a third-party switch, a non-Cisco switch like Huawei or Juniper Networks, Arista, Nokia, etc. Which action should be taken? Sorry, this is just, I've changed it recently. Okay, which action should be taken? I should configure on both these switches an IEEE 802.1p. This has nothing to do with sending VLANs through a link. No. Configure IEEE 802.1q on both sides. Can this be done on a non-Cisco device? Since there is something says IEEE, this means that this code is open standard and supported on all the different vendors. A third party, Cisco, all of them do support this protocol, and thus this is a trunking protocol, and the trunking protocol is a protocol that allows inter-switch VLAN communication to happen between two devices. So yes, ISL is for Cisco only, and DSCP is not to be talked about here. Okay, this is for layer 2 quality of service, as I remember. Yes, so that will be only B. Which protocol prompts the WLC to generate its own local web admin SSL certificate, the digital certificate of encryption, for GUI access? either HTTPS secured, which will ask for an SSL certificate and will generate it. Radius is only for AAA, not for encryption and such, for authentication and authorization, as well as TACAX Plus. The difference between them is that this guy is a Cisco proprietary, it's faster, it's safer, and it's more flexible when it comes to authorization. But both of them are AAA, has nothing to do with encryption and SSL certificate. HTTP is not encrypted. The HTTP secured is the encrypted one that asks for the digital certificate and enabling the encryption. I hope so far I'm doing good. Question number 9 says, in a software-defined networking or architectures, which plane is distributed? So this means that this plane is available on all the devices or nodes in the southbound and responsible for traffic forwarding. So when there is a traffic or packets and there is a known destination, this plane will be the one to handle, which will be the muscles or the mechanics that does that. The management plane, sorry, this is only for remote access and management like console and such. No, the control plane could be, but just before you think about forwarding or making decision, think about the word distributed. We know that, and I have talked about that many times in chapter 7 in the course, in the complete course on this channel, that the control plane in the SDN network is isolated only and will on the top umbrella of the network and will make all the decisions of the entire network from up there and push its own instructions to the other devices, to the nodes in the southbound. So all the devices or nodes in the southbound will be brainless, depending only on the control plane that is in the top of the umbrella. So definitely not the control plane, neither the policy plane, not about that, but the data plane are the muscles that performs packet forwarding or traffic forwarding. At the same time, yes, they are distributed, and every single Cisco device has its own data plane. We did talk about that a lot in chapter 7. Question number 10, which means that we are almost half the way there to finish the video. Which function is performed by the collapsed core layer in a two-tier architecture? In a three-tier architecture, you have the core distribution access. In a collapsed architecture or in a two-tier architecture, both of them refers to the same design. We have collapsed both the core and the distribution to become the aggregation layer that will be connected to the access layer. So what will be happen here? Let's see. It's either something that used to be performed by the core or the distribution before, but now since both of them are merged in one single layer, then this layer should perform both the old operations. So enforcing routing policies, the distribution layer before did that, so this should be your responsibility. So I can do that for now. 1 minute. Marking interesting traffic for data policies. QoS should be enabled in the access. No. Attaching users to the edge of the network. Edge of the network in this design means the access layer itself. This is the definition of the access layer. No. Applying security policies should be in the firewalls that either installed before the client or before the internet. So not you, but there is one correct answer, which is the routing policies, and this is the distribution responsibility. In that case, I will make it the aggregation responsibilities since it's a collapsed architecture. Where does the config reside when a helper address is configured to support DHCP? In a cases when I have normal DHCP, I will have a host requesting a DHCP or an IP addressing assignment from the nearest DHCP server. In the case of IP helper address, I will have a remote DHCP server that is connected to me through multiple routers so that it will be able to reach me. So where should you configure the helper address? On the router closest to this server. Let's make this one is this server here. So I should maybe implement the command on this interface, and that will be extremely useless. Why? Because this host will send the broadcast message all the way to this interface, and you know what happens to a broadcast message when it reaches a layer 3 interface? It vanquishes, it disappears, because those interfaces, they swallow them and they send them like to a black hole. This is the job of a layer 3 device or a router or a layer 3 interface. It isolates completely every single port in a single or isolated broadcast domain, and thus a broadcast message will stop here, asking nicely that I only need an IP address. So the router, so this interface, for a matter of microseconds, will say, let me look back and see if there is a DHCP server here. Sorry, there is no pool. The pool is closed. Go home or find another beach. There's no pool today. Okay, and that way implementing the command on this router is useless. On the router closest to the client, and this is what I am talking about, implement the helper address command on this specific interface so that it will have a small mirror here reflecting that message up to the DHCP server. And we did that in a real lab on the channel, on the CCNA 231 complete course. Yes, I did that. On every router along the path, this will be a big headache and make this protocol useless, and it's not in that way. On the switch, I should configure helper address on a layer 2 device on a trunk interface. Are you sure? No. Yes, we have done that on a switch, by the way, before, but I did configure that on interface Vlan, which was a layer 3 interface, by the way. It's an interface Vlan. Yes, refer to this exhibit, question number 12. Network admin must permit the SSH access to remotely manage routers in the network. The operations teams have this address to be a destination in my access list. Which command will accomplish this task? I can see that the interface gigabit Ethernet 01 has the access list extended in. So when it's receiving traffic, it will read that list with an IP address, and that access list has 4 rules. Deny the ICMP, whatever, this will not affect my SSH. Deny everything from anyone heading to 10.20.1.0 but /24. So this is combining both /25 and .128/25 as well. So this is killing every IP technology from passing the interface, and this will not allow my SSH session to pass through. Number 3, permit everything to 10.10.1. Sorry, I care about 10.20 now. I don't care about you, neither you. You will not affect my job. And permit TCP22 SSH to 10.20.1, and it's /25, no problem. Okay, but I'm sorry, there is a rule before you that kills the effect of rule number 4. In that case, I need to do one of 2 things. Number 1, to swap between these 2 to make this in a higher role or sequence from this one. Number 2 is to completely erase that role so that at least my quest will reach the 3rd or the 4th rule here to be read, and thus it will be forwarded. So access list, add a command of access list permit UDP. What does UDP have to do with us today? Nothing. Delete the deny TCP. No, I need that. Okay, access list extended or 2699 permit TCP 22. There is a permit already. You are doing nothing, and no. Finally, it says no access list deny IP any, and this will erase this command here or this rule, and that will make my list works properly. Yeah, okay. 12. 13 says, what is the purpose of traffic shaping? Traffic shaping is like when you have that small sharp knife and a piece of wood, and you would like to keep sharpening that surface to make it in the end look equal. And this is what will happen to your interface when you monitor its own traffic by an SNMP monitoring system like PRTG. You will find that interface fast Ethernet 01 has a steady traffic of 10 megabit per second for the last 60 minutes, and this is shaping. Okay, this is done by enabling, by the way, chapter 1 or the architecture chapter of the CCNP Enterprise Core 35401 on my channel in English has a really detailed explanation about quality of service, and shaping, including and mentioning the tools of shaping, which are queuing. And queuing is creating lines for packets to wait, packet 1, packet 2, packet 3, and only one single door that passes 10 megabit per second of traffic, and thus I will send 10 megabit. After it reaches another 10 megabit, another 10 megabit, all of those other 10s are waiting in their queue for microseconds or even seconds, I don't know. Okay, so this is shaping. So it mitigates delay over slow links. Actually, it's creating a bit of delay because it creates a queue for waiting. It provides fair queuing for that buffered flow here, the flow that I'm saving for later in my queue. Yes, it limits the bandwidth that flow can use to limits the flow, not marking, not classification, it's policing, I believe. And B, a marking mechanism, it's not a marking mechanism. Marking is marking and shaping is a different mechanism. They are both isolated from each other, but each one of them needs the other to operate. Okay, so provide fair queuing seems correct and enough today to be chosen for that question. Which config management mechanism uses TCP/22 SSH session login by default when communicating with the nodes in the southbound? Ansible, Python, Puppet, Chef. In our course, we have taken only these three. In the Enterprise Core course, there will be these three again with extra details, plus the Ansible as well, because this guy actually is the most popular application to be used worldwide nowadays in 2020 21 is yet to come in a few days. Okay, hopefully with health and vaccine. Yes, so which one actually uses TCP/2020? The unmentioned Ansible does use SSH by default. Yes, so just for the record, Ansible is the one that uses SSH by default, and we will talk about that in the core course if you will ever follow me for that course later. Refer to this exhibit in question 15. If OSPF is running on this network, okay, this is OSPF running between two routers. Each router have its own specific local network behind the scenes. Okay, how does R2, this guy, handle traffic coming from site B, whatever, heading to a network in site A? So we would need a routing protocol to push the traffics either from this interface, that interface, or from both at the same time. Let's see, based on the routing table of R2, it says if you wanted to send something to 10.10.10.8, I don't care about it. Send something to 10.10.12, I don't care about it, I'm sorry. Send something to 10.10.13, yes. .0/25, so this one ends with a broadcast ID of 127. You are not included, I'm sorry, so no. And 10.10.10, yes, so no one mentioned 10.10.13.122 it here. Perhaps the default gateway, default route will deal with it. But gateway of last resort is not set, so there is no default route, dynamic or static one command configured on R2. Unfortunately, whomever wants to reach that one will not be able to. So it load balances? No. If it was destined to this network, it will be load balanced because it's equalized between both fast Ethernet 01 and 02 route. No, it's unreachable and discards the traffic. Yes, it will not be sent through neither 02 nor the 01. I'm sorry, it will be unreachable. Okay, we have finished almost 70% of our questions. I hope that you are catching me so far, and I really hope that just like I see, most of those questions are really simple, makes more of sense, and we did really mention them in our course. I hope you do that as well. I hope you see that the same way that I do, except for the Ansible question. Yeah. 16 says, which command configures a floating static route, the backup hiding or the backup hidden route? Sorry, what's wrong with you? The backup hidden route to provide a backup to the primary link. Who's the primary link today? let's see. An IP route by default, no problem, to that destination, but with a missing backup administrative distance higher than the value of 1. So this is not a command of a floating static route from the beginning, it's a primary static route. No. The other command says IP route to this network that has that specific mask to this next hop, yet no AD administrative distance is missing. IP route again just like A, no difference at all, but D says hopefully IP route this network /27 to this next destination, and we do have it here. I have it right here. There it is, this network, and it's routed via static route. And let's see. Yeah, yes, static route, and you can find the AD here right away, and that same ID AD administrative distance, so it will be D. If the primary one fails, the backup will show up here, and in that case I can see the backup already. It's clear. Seems that the main one has failed already before the question even written. What is a practice that provide network from protects a network from VLAN hopping attacks? Attacking your network by connecting a device to a specific VLAN and rogue from that VLAN. Enable dynamic ARP inspection DIE, which we have talked about in chapter 5 of this course, I believe. Yes, we did. But no, this is not in that way, not by binding MAC, no. Configure an access list to prevent traffic from changing VLANs. I don't remember such thing. Change the native VLAN to an unused VLAN ID. Perhaps VLAN 300 or VLAN 3000 is a VLAN that's not used in that network at all, only created in switch 1 or switch 60 maybe, and that guy, foreign guy, can't connect its own computer or any other device to switch 60 because switch 60 is not in the data center, so it's not really physically secured. And that way whatever that guy sends through VLAN 3000 will go nowhere, because VLAN 3000 is only not available, only lives in switch number 60. So I believe C could help us really. Implement port security on internet facing VLANs. Are we talking about? Interesting how an internet facing port might carry a VLAN. It should be a layer 3 interface carrying like a BGP or ISIS. Perhaps external VLAN, not external OSPF, but not VLANs. But C is correct. We can neglect D because C makes sense, and that should be enough. 18 says, which tech can prevent client devices, okay, from arbitrarily connecting to the network without state remediation, without being limited, without being monitored and asked every while another of how are you today, are you enjoying your service here, do you need anything, are you really staying all that long, okay, any checkout please. Okay, this is the state remediation. This is the third brother A of the AAAs, the authentication, authorization, and comes that third important guy, accounting. This guy is the one that does the state remediation by looking to that interface, to that host, to that client, and asking it every while another of, you're still connected? For how long? You want to renew your authentication again? Are your credentials staying up for more than 4 hours? Are you staying for more than 4 p.m. today? Extra time maybe? In that way, this is what accounting does. So 802.1x will be that tech. Well, since 802.1x carries AAA, then might be. An IP source guard, I have no idea about that, but I don't think it's from a matter of really security. It's a matter of monitoring and performing something. Yes, MAB, which we have talked about a lot in chapter 5, but of the Enterprise Core course, because it's totally not on, both of them are totally not on the agenda of the CCNA, so I haven't mentioned them at all. But MAB can or does authenticate you without AAA, depending only on your MAC address, not asking for a username, not for a password, and thus it authenticates you by bypassing depending on your MAC address. So this is what a map does, and there is no remediation here. 802.11 is wireless and no, okay. 802.1x is good. It carries AAA and AAA has accounting and we are good by accounting. What facilitates a telnet connection between devices by entering the device name. Interesting. SNMP have nothing to do with telnet or name server or domain name worldwide through the internet. A DNS lookup perhaps, and not a syslog, I'm sorry, neither the network time protocol. The domain name server lookup perhaps will make use of resolving the name of your device throughout the internet when you would like to telnet it remotely. So yes, it will only be, yes, we are almost done today. How does the dynamically learned MAC address feature function? When a switch automatically discovers and records in the MAC table the MAC addresses of the neighboring or the adjacent devices. How does that happen? The CAM table, which is the content addressable memory table, which is a part of the RAM, the random access memory of your switch, that stores MAC addresses and shows those addresses to you in the, I forgot the word in English, in the view, let's say in the view of the MAC table, but actually whatever you are seeing in the MAC table are only a reflect for the information stored in the CAM table. In detail, I have talked about that in chapter 1, architecture of the Cisco Enterprise course 354.1, because it was mentioned in the agenda there, not in the CCNA. So the CAM table is empty until an ingress traffic arrives at each port. I will have to explain that. Bear with me for 2 minutes. If you have a switch, you have just bought it, and it's actually not one, 5 switches, and you wanted to connect it in that way. The star topology, 4 switches, all of them are connected to a single switch, the main one, switch number 1. And just after connection and every physical thing is done, you would only like to power up the 5 switches and leave them for 10 up to 30 minutes. Do you think that 30 minutes later the chicken will grow up in the oven? No, because you haven't started the fire correctly in the way that you think you did. What I'm pointing to actually is not just by operating up or powering up all of those devices. This means that the automatic or the dynamic learning MAC address feature will operate, and now right now at least switch 1 knows about the MAC addresses of the other guys. No, you need to provoke it, and this will be done by if any frame was sourced from this switch number to whatever destination and reached the switch, and the switch will look up to the destination MAC address in the frame, sees F's all the way, F all the way, which is in the decimal language once, like a broadcast, because in the broadcast we have 255 255 255 255, the maximum of the maximum of the maximum. Okay, so this is the same thing in the hexadecimal languages. The maximum bit here is not the ones, because it's not a binary language of only zeros and ones. It's not 255 like the maximum value in the 2 to power 8 decimal language. It's not in that way or architecture. It's actually a hexadecimal language where the last and biggest value digit is F, and thus all of them are F's. So the switch will says what a frame, a polite and perfect frame should have destination MAC address, a source MAC address, and this is how I deal today, and this is how I deal here. But sending me rudely a frame that has a missing field, which is the destination MAC address, will unfortunately made me send an ARP request to all of you in a broadcast thing situation, Actually choosing the F's right now, just like the first guy did and provoked him, but okay. And in that way I will have to learn that missing MAC address and record it in my table, and definitely that will be first written in the count table. So this is what happens: provoke every single port so that it will start making use of this one, that one, this one, and knows the destination MAC address was later applied by switch number 5, and then that way as a source MAC address for switch 5, I know that this specific MAC address resides in switch 5. Switch 5 is connected to interface Ethernet, fast Ethernet 05, maybe in that way. Okay, so this is how I add entries to my MAC address automatically. There is a bit of a manual step that you need to do, but the next other steps will be automatic. Switches dynamically learn the MAC addresses of each connecting CAM table. It's not that really dynamic, I have talked about that. The ports are restricted and learn up to a maximum of 10 dynamic MACs. It was limited by 300 total, but it's not limited by per port, and right now it's even bigger number or value. It requires a minimum number of secure MAC addresses to be filled dynamically. I know you are free up to filling from 0 up to the maximum limit, so it's simply A, just like I have explained, and the video is not done. 21 says, when implementing a router as a DHCP server, which two features must be configured, otherwise your DHCP server will not operate as the correct healthy DHCP server, or it might not operate at all. Number one, the relay agent informations. Perhaps there is no relay agent. This is not a mandatory, not a must. The database agent, leave it for the binding to discover. The address pool, of course, because it contains the network with their ID and their subnet mask, and definitely this is a must. The smart relay, what is that? No. The manual bindings, do you remember that? We need to exclude the same default gateway address so that you would avoid the duplicate address assignment. If you remember that, then you know that of all the examples and the mega labs that I have used the DHCP server tech or protocol in, I never left the config of the DHCP without using the command of ipdhcp exclude address 10.10.10.1. so this is mandatory before you have, and you will have, the duplicate address assignment. 22 for today will be the last one. Which command must be entered to configure DHCP relay? A lot of DHCP questions today. I believe they were 3 or 4 so far. So the command of ipdhcp relay, anyone remembers? We did that twice in the course. If you have seen my course, it was IP helper address, and there is a previous question 15 minutes ago, I believe, or 20 minutes, saying that where will the helper address resides. So if you had an exam that has both of those questions in, one of them will help you by remembering the correct question of the other. This is how a question will help you actually. So IP helper address will be the only correct answer for question 22, and question 22 at minute 43 will be the last question to be discussed today, the last question of December 2020, and this will officially advertises Christmas. Thanks a lot for watching. I hope to see you in the upcoming videos, and goodbye.